Hi there, this is Vahid from VRF Education channel, and it's the fourth session of object-oriented programming in Python. Till now, we got familiar with the basic concept of object-oriented programming, such as classes, objects, methods, and fields. And we have learned that those methods that we declared inside a class without any decoration and any other stuff, just adding one parameter named self, these are object methods. This means that to calling them or to make use of them, we should first instantiate from that class, and then through that object or through that instance, we can call that method. And then in previous session, we categorized class fields into two different categories: object level and class level fields. Class level fields are the fields that shared among all the instances that created from that class, and the object field are those that are specific to objects, and each object has its own value for those fields. For methods, we also have some class level methods. Those methods are somehow binded to class itself, not to objects. We can call them without instantiating from that class. These are a specific type of method, and we can use them for specific purposes. In this session, I'm gonna talk about them. To convert a method to a class level method, we just annotate it or decorate it with this decorator, class method. So let's go to VS Code and check class methods in practice. In previous session, we talked about instance level or object level variables and compared them to class level variables. Here we have a complete demo for them. Variables inside the constructor or even other object level methods of the Python considered as instance level, and to access them we should use one instance or one reference to an instance of the class. For example, here I can use p1.x or y or z, anything. And the variables declared outside a scope of the constructor or any other object level methods are considered as class level methods, and to access them we can use the class itself or again using the instance of that class. And we said that any methods that declared inside of a class that has at least one parameter, the parameter with the with notation we called it self, is considered as instance level. To access them we should use one instance. What does it mean? Here we have an instance level method display, and we called it a couple of times. Now if I run the application, you can see these two methods called and some output printed on the console. So if I use the student, the class itself, and call the display methods, what's happened? Let's comment these two out. Now if I run the application, it says display missing one required positional argument self. We said in the previous session that when we call a method, an object method or instance method, using this notation, Python interpreter automatically pass this reference as the self parameter. So if I just pass the Vahid as a parameter to display method that called throughout the student class, let's see what happened. The output is just the same as I called the Vahid.display method. This is the same. I passed the parameter to display method and said call it using this object. And this is the spirit of object-oriented inside the Python. It's somehow different from the other languages, especially C family languages. In those languages, we should only use method calls over instances, not we cannot call them over classes. But in Python it's somehow flexible, and you can use it in both ways. So how can I use some methods inside the class that is not related to any object? It's related to the class itself. For example, I can call it over the student class without providing any instance. These are called class methods, just like the class variables that we saw before. And these are equal to static methods inside other languages such as C# or Java. Class methods are again a regular method inside a class. For example, let's add it to point class. Let's imagine the scenario. I want to create a predefined point that is referred to the 0 and 0 as xy's. So I can call it here. I can create a method. I can create an instance here. P4 equals to point, and x and y equals to 0. And again, for example, I want to create it a couple of times. P5, again, point, 0 and 0, and go on. Here, because it's somehow static, I can add it to the point class and call it through the point class. I create a method named 0 inside the point class, and then just return it an instance of the point class with the position of 0 and 0. And here I can call it point 0. Anytime I want to create a 0 point inside my application, I can just call this method. Okay, this is much more readable than this one, and I can use it anytime I want. And this is just a simple example. In future, I will get you some more complex and more realistic example. So I want to create a method inside the class without passing any argument. Here, you should create a method named 0, def0. We definitely need it. And by convention, instead of naming the first parameter as the self, we call it CLS. It's a very common convention between Python programmers. And here, I'm just going to return an instance of the class with the parameter of point 0, x and y 0. Okay. And by convention, Python always assigns the class itself to the CLF, just like it assigned the instance to the self. So we can omit this one and call it CLS. CLS in this example equal to point class. Okay. And this is just a regular method, not a class method. To cast a method to a class method, we should decorate it with the class method decorators. Now, this method is a class level method, and we can call it through the class itself without instantiating. Class method or decorator in general is a utility to enhance or to extend the functionality of another methods. These are a special type of decorator, and I have recorded a video about the decorator in Python, and I explained it completely, but unfortunately that video was in Persian, and I will record another one in English very soon. By now, just imagine or just consider it as a notation that you should add to a method to convert it to a class method. Now, I want to comment it out and go up. Here I create P5, and I want to call P5.display. Point 0, 0, and it's the z variables that we just changed the value of class level variables here, and these two variables or these two class level variables that we checked in previous session. So every time I want to create, for example, a point that refers to the center of the screen, that is 0 and 0, something like here, we can call the 0 method. And if I change the location of the center, for example, to the top of the page, I can come here and change it, for example, to 10 and 10. This is the new center or the new 0 of my screen. And every time you create the point 0, it will refer to this point, not the real 0 and 0. Learn it? Here we have 10 and 10. So what if I have, for example, P4 here and create it directly from point 0 and 0, and P4 dot display. P4 always refer to 0 and 0, not the center of the screen. By using this class method, I'm assured that these points that I'm need them to point to the center of the screen, always they refer to the point that I considered it as the center of the screen, not statically to the 0 and 0. This is the main benefit of static methods to creating some objects based on some logic inside our application. I hope you get the concept, and we will get you a lot of example during the series. The more realistic one, I'm gonna tell you a lot about this kind of decorators in Python. and I'll see you in the next session. I hope you enjoy it.